All right. Good evening. It is 8 o'clock, so we'll go ahead and get started. So the material for this week was all about functions. And functions are one of the most important concepts in any programming language, not just Python, but all programming languages use functions, and they are incredibly important, as we will see this evening. Okay, so what is a function? A function is really just some code that somebody else wrote and that you would like to use that code. That's what a function is. Just think of it like code that somebody else created and you want to use that code. So why is that important? It's important because we don't want to do what we call reinventing the wheel, right? You've heard that in probably a lot of other contexts, but it applies to programming too. If someone has solved a really hard programming problem before, then do we need to repeat all that work and also solve the problem from scratch? No, that doesn't make a lot of sense. Let's use the work they've already done to solve whatever problem that we're trying to do. So they will create a function and then we will call that function, which we will see how to do this evening. So, as I said, the most important thing to remember about functions is it is just code that someone else created that we want to use in our program. So with Python, there are some built-in functions, some functions that just exist within Python itself. There are some functions that other people have created and we can just kind of automatically use from Python, and we'll see that. And then, of course, we can create our own functions, which is really part of your assignment this week, but it's covered in the material, and then we will see how to do that here tonight. Okay, so let's talk about some Python built-in functions. This is code that Python already provides to us and that we can just use kind of automatically. Would it surprise you to know that you have already been using some of the Python built-in functions? One of them is print. If we just say print hello world, and if we run that, should know what's going to happen. It just prints out hello world, right? But this print is a function. It has a name. The name is print. And then you see here we have this open parentheses and close parentheses, right? And in between here is what we call the arguments to the function, meaning this function does something, and this is the information that function needs to know in order to accomplish its job. Now, you've been using print for several weeks now. You know that whenever you say print, and then inside the parentheses, you tell it whatever you want it to print, right? Well, that is the Python built-in function to print, meaning somebody else wrote some code so that whenever you run this function, it literally puts the characters in your output window, right? I don't have any code wrote here to put some characters in my output window. Print does that for me. So somewhere else in Python, somebody made a function called print, and you give that function whatever you want it to display on your command line. And then somebody else made up all the code behind the scenes to actually make that happen. So we are calling their function. That's the terminology we use, is we call the function when we use the function name, open parentheses, put the arguments to the function, and then the close parentheses. That's how you call a function. So that's the Python built-in print function. There are other ones that you've used. For example, you've used the input function. So let's just say the name is equal to input, enter your name, right? And then here we'll just print out your name, right? We're using a lot of functions right here. So we're having a variable. It's going to be equal to this function called input. And with the input, that's the name of the function. We have our open parentheses, we have our closed parentheses, and in between here, this is the information that the function needs to know in order to properly operate. And you should know by now that whatever you put in this argument right here, that's just what is displayed on the command line for the user to know what to do, right? So of course, when we run this, it says enter your name. So this input function, one of the things that it is doing is printing that to the line, right? And then you type in whatever your name is, and then we print it out again. So the input, the function exists somewhere else in Python. You don't need to worry about where it exists or how it works. You just know that you give it this input and it gives you some output in return. So the kind of terminology with these functions are, this is the input to the function. These are what we call the arguments. And the function has some kind of output. It produces some answer. Not every time. It depends on which specific function it is. But in the example of input, what does it give back to us? It gives back to us whatever we typed in, right? So here, I'm going to say my name is equal to whatever that function gives back to us. We know this input, it gives back to us whatever we typed in, and then we just print whatever we typed in, right? This is stuff you've been doing for a couple of weeks now. So there it is. There's the input function working. All this right here is done by the input function. We typed in Dan, and so Dan is what it gave back to us. We say that the terminology is the function returns to us whatever we typed in. So a function has its input arguments and it has its return value. And since the input returns to us whatever we typed in, I want to save that in a variable. And then we'll print it out. Now you may ask yourself, why don't I have something equal to the print, right? And that's because print doesn't actually return anything to us. And just logically thinking, forget about Python for a second. Just think logically for a second. It makes sense for print to not return anything to us. The only thing we're asking it to do is display something on our command line, right? And so there's nothing for it to give back to us. That's kind of the opposite of input. Here, I'm asking Python to give me some kind of input, right? Tell me what the input is. Tell me what the user typed in on the keyboard. And so it does make sense that it returns something to us. And whenever we start creating our own functions, you'll see how we can differentiate between a function that returns something and one that does not return anything. Okay, so those are two Python built-in functions, the input and the print. There's a few more. Let's say, and we're just going to give a few examples. There are many, many, many built-in Python functions. We're just going to talk about a few just as we review functions. There's one that is called min. And if you give min two numbers, it will return to you the smaller number. So let's just say A is equal to that because I told you min returns to us the smallest value. So we're going to say the variable is equal to whatever it returns. And min takes two arguments. It needs two inputs. And it's the two numbers you want to compare. So now if we print out A, it should do what? It should print out the number 3, right? Get rid of this stuff. Oops. What's going on with my clicker here? Yeah. There we go. All right. So if we run that, of course, it prints out the number 3 now, right? Because that is the smaller number, and min is a built-in function. It takes 2 arguments, and it returns to us the smaller number. Likewise, there's one called max. It will return to us the bigger number. If we run this, it gives us 5 because it's the bigger number. And you can use variables to do it. We can say A is equal to 4, B is equal to 7, and then C will be equal to the max of A and B. That works just fine. Max is the name of the function. Then we have an open parentheses, a closed parentheses. In between, we have the arguments, and they're separated by a comma. So this means it takes 2 arguments, and it will return to us what the bigger number is. If we run that, it should give us back 7, right? AB. Oh, maybe I didn't save it. Save. Oh, because I'm printing out A. I want to print out C for it return to us. There we go. And there we go. It prints out 7. So those are just a very few number of Python built-in functions. There are lots of them, and depending on what you want to do, but those are just a few of the Python built-in functions. We talked about the arguments. The arguments are the input that you give the function. Like the argument for print is just one. It just wants one thing, and it's what you want to print out. For max, it needs 2 arguments. It's the 2 things you want to compare and see which one is bigger. But there's nothing wrong with, say, a function that takes 10 arguments. It just depends on what the function is and what it's trying to do. And of course, the return value is what the function gives back to us. Okay. So that's some Python built-in functions. Now, let's make our own function. Okay. And here's how we make our own function. First, we need to decide, what do we want our function to do? Okay. Let's say we want our function to compute the area of a circle. We just want a function to do that, right? Instead of, well, we'll see whenever we start putting the program together. But we want to make a function to compute the area of a circle. So what do we need to know to compute the area of a circle? What's the formula for the area, right? The formula is area is equal to pi times r squared, right? Pi times r, with r being the radius, right? That's the area of a circle, right? So mathematically, in order for us to compute the area of a circle, what do we need to know? Well, to get the area, we need to know pi, and we need to know r, right? We need to know the radius. Well, pi is an automatic number, right? We know what pi is, 3.1415927, and then a bunch more numbers, right? So we don't need to tell the function what pi is, because pi is just kind of an automatic number. It's a constant number in math, right? But we do need to tell this formula what the radius is, because the radius can be anything. Pi is only one specific number, but the radius can be anything we can imagine, right? And so for our input, we need to give it the radius, right? That's what the math needs to know, what the radius is to do the computation. Okay. What is going to be the output of this math that we're doing? Well, it's going to be the area of the circle, right? And this is kind of all we need to know to compute the area of a circle. So let's make a function that does that, and then we'll use our own function. So it starts out like this. You start out with DEF. It stands for define. Then we have to give the name of the function, name of the function. Then we have to give it the arguments. And then we put a colon. And just like we did with the if statements, here is the body of the function. Anything that is tabbed in after this point is part of the function. Just like, when we did the if statements, if something, you had a colon, and then do this, do this, do this. And now this is after the if, right? Kind of like we did this with the if statements. We had if something, and then anything that was part of the if, was tabbed over. And then as soon as you get to something not tabbed over, then that was the end of the if statement. It's the same thing here for our function, except we have DEF for define. We want to give the name of the function. We have the open and close parentheses. Inside here is the arguments. What does the function need to know in order to do its work? Then we have the colon, and then anything that's tabbed over is part of the function. All right, so instead of calling this name of the function, let's name it something appropriate. That's actually very important in programming, is for your variables and for your functions, you want to name them something appropriate for what it is they're doing. So for this function, we're computing the area of a circle. So let's just name the function compute area of circle. That makes sense, right? That'll be the name of the function, and it describes very well what it's actually doing. All right. So for the arguments, what did we say the function needs to know? Its input needs to be the radius of the circle, right? So it only needs to know that one thing. So instead of saying arguments, let's say the radius. Let's name it something appropriate. Let's say if it needed to know two things, then we would do it like this. Something else. That's if the function would for some reason need two somethings. This is how we would do it. We'd have the name of the first one, a comma, and the name of the second one. But for our compute circle, we only need one thing, and radius is the only thing we need. So that's what we're going to put. And the name of this doesn't matter. You can call it whatever you want, and it'll still work fine. But, that's not very descriptive. Radius is much more descriptive of what it actually does. So now inside the function, let's compute the area. Say the area is equal to pi, which is 3.1415927, something else, times the radius, right? So if we want to compute the area of a circle, and this is the radius, then that's the formula for the area, right? Okay, so we have computed the area, but now we need to look at the output. For the output, we want to output the area of the circle, and so we used the keyword RET, return, actually the full word return, and then what do we want to return? We want to return the area. And that is our complete function for computing the area of a circle. Again, DEF just means I'm getting ready to make my own function. Compute the area of the circle is the name of the function. Then we have these open and closed parentheses. Inside of the parentheses is all of the input that the function needs to know in order to operate. And the only thing it needs to know is the radius, so we give it the radius. Then we tab over. Anything that's tabbed over is part of the function. So we tab over and we say, okay, let's do the math. The area is equal to this formula. Notice this radius is this radius. This radius is the parameter, is the argument to our function. And here we are using that argument. All right. So we're saying the area is equal to pi times this radius that you gave the function. And we're going to return the area, which was the computation. So that's the function. So now let's use the function. So as I said, when it's tabbed over, it's part of the function. Now when it's not tabbed over, this is not part of the function. So let's say this area is equal to compute the area of a circle of, say, radius 2. Now let's print the area. So what's going to happen here is, Python, it executes from the top of the file down. So whenever we start running it, Python is going to start doing all this stuff. And of course, it sees these as comments, so it just skips it. Then it's going to get here and it says define. Oh, this is a function. So it processes this, but it does not execute it yet. It does not execute this yet, even though it starts at the top and works its way down. It sees this and knows it's part of a function. And excuse me, it knows it is a function. And so it kind of records down that information, but it doesn't actually execute this code yet. It does not execute this code until you call the function. And just like we did with print, we call the function by using the name of the function, using the open and close parentheses, and then giving the function whatever input it needs to know in order to properly operate. It needs to know the radius, and we can see that by looking at the function. Oh, this is the name of the function, and it takes one argument, and it's the radius. Okay, now we're going to call the function, so we use the name of the function, open parentheses, close parentheses, and whatever input it needs to know. And it returns to us the area. So we say the area is equal to whatever it returns. And then we're just going to print it out. So let's run this and see what happens. What is it going to give to us? It's going to give to us the area of a circle with radius of 2. And is that right? We can take a calculator. That's where our test procedures come in handy. So we take 3.1415927 times the radius, which is 2, times the radius, which is 2. The answer is 12.56 and some change. That's what our program gave to us, so our function is working properly. So while we're looking at this, well, we need to talk for a second about the flow of execution of the program, which we just briefly mentioned it already, but it's important to label it as the flow of the execution of the program. So, like, as I said, Python's, whenever you have a file, it starts at the top and works its way down. So it starts here, it sees these are comments, so it ignores it. It gets to line 5 and it says, oh, define this name and all this. Oh, this is a function. It does not execute it yet. It just kind of takes a note that this is a function that exists. Then it gets to line 9, there's nothing. 10, there's nothing. Line 11, it's a comment, so it ignores it. Line 12, okay, this is no longer part of the function, so it's going to execute this. So it sees that you have a variable is equal to this function right here. And so since Python has already knows this is a function, it knows it because it started at the top of your file and worked its way down, and it took note that you made this function. So it says, okay, you have this function with this name and this parameter. So whenever Python is at this line, what is the next thing it does? Does it go here next? It does not. The next thing it does is it executes that specific function. It says, okay, you're calling this function. So now instead of going to the next line, I'm not going to go to the next line. I'm going to go to where this function is. So it executes this and then it jumps up here to this function. Okay, so this is a comment, it ignores it. This is a line of code, so it executes it. This is a line of code, so it executes it. But this one is special because it has this return. So when Python sees this return, it remembers what you are returning. For here, it's just whatever we computed. And when it sees return, it goes back to where it was before it executed the function. So it goes back to where it left off. And this is where it left off. This is what it did. So it knows, okay, when I see return, I need to go back here and go to the next line. So the next line is the print. So once again, briefly, Python starts at the top of the file, works its way down, comment, 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 it ignores it. Oh, this is a function. I'm going to make an internal note that this is a function. This is where it's at. Okay, next line, next line. Oh, it's a comment, ignore it. Next line. Oh, okay, this variable is equal to this function. You're calling the function. So I'm going to go start executing the function. So that's a comment. It does this math because it's the next line. Next line, it returns that value. Oh, return, I need to go back to where I left off. This is where I left off. So it goes to the next line, which is the print. CSPItter in action. Let's have the user input a number. Num. Enter a radius. And then we'll have another area is compute the area of a circle with this radius. Let's run that real fast. Oh, misspelled it. Inputs. There we go. All right. So Python executed this function. It jumped up here, executed this code. It returned to where it left off. It executed the print area, which we can see right there. There's the print area. It goes to the next line, which is this input, which we can see it's doing right now. It's waiting for me to type it in. Say 2.5. Oh, num. I made a mistake. I'm going to fix my mistake. It's actually kind of good that I made this mistake. So notice that I named this variable num, right? Why did I not name it radius? The reason is that it doesn't matter. Because whatever I type in, I'm going to say that is the variable num. And num just represents whatever number I typed in. And that's the number that I want to use for my computation. So kind of the point is, even though I name it radius here, outside of the function, this radius variable does not mean anything. It actually does not exist. This radius only exists within this function. And what happens is I'm going to say the number I typed in is num, right? And so I'm calling my function with the variable num. So what is happening here behind the scenes, and it's actually important to know this, is when the code comes up here to execute, it is not using the variable num. It's using whatever num represented. Num represented the value of whatever I typed in. I typed in 2.5. So num is the value 2.5. So when I call this function, I'm not giving it the variable num. I'm giving it the value that num represents. So I'm giving it the value 2.5. So when it comes up here to the function, it's going to say, okay, radius is whatever that value was. So if num was 2.5, when I come up here to my function, this radius is that value. So, like I said, it's important to differentiate that you're not giving it the variable num, you're giving it the value that num represents. Another important thing, so, let's get rid of this one for a second. Let's just keep this input. So I'm inputting this num, right? If I do this here, is this going to work? The answer is yes, it will work. Most of the time. Let's watch. 2.5. Oh, I need to print out the answer so we can see it computing it, right? So if I run this, it does work, right? But this num is not part of the arguments, right? I'm using a variable, I'm using this variable num, but the variable exists outside of the function, meaning we don't make a variable num inside this function. There's no parameter called num. I use the word parameter and argument. You can use them interchangeably. If you hear me say one or the other. There is no argument num. So where does this num come from? It comes from outside the function. It's right here. But like I said, this code is not part of the function, right? But I'm still using it. Python will let you do this. I really wish it would not let you do it. I really wish Python would not let you do this, but it does allow you to do this. However, this is extremely bad as far as style and professionalism and things of that nature. And I probably will count some points off if you do this. And what I mean by this, just to make it perfectly clear, is this num exists outside of the function. It's created right here. The num equals to whatever. That's where it's created. And since this exists outside of the function, you should not be using it inside of a function. If you need that value as part of your function, it needs to be an argument. And that's actually exactly what we're doing. We're saying this num is whatever you type in. We know that our function needs that value. And so here we're doing the right thing and giving it as a parameter. Right. But like I said, we're not giving it the variable num. We're giving it whatever value it represents, which ends up being this radius. So this needs to be radius. What it is when you have the num here, that's what we call using global variables. You may hear that terminology. Global variables are actually a really bad concept. And you should not be using global variables. If you go on to a professional programming career and you use global variables, you're probably going to get your hand smacked and told not to do that anymore. Okay, so do not use a variable that does not exist within the function. Meaning, if I want to use a variable, I need to put A equals whatever here. B equals something else, right? Now I can use A and B inside of here. or I can use a variable that is an argument to the function. That's okay. What is not okay is using a variable that exists outside of the function. So don't do that. Okay. So that is functions in Python. And that's pretty much all of this week's material. Now for your assignment, I looked at it a couple days ago. If I remember correctly, it's kind of a repeat of the previous assignment, but you have to use functions to do some of the work of the previous assignment. So you're kind of reworking that code to incorporate functions into it. And you have to use the functions. The assignment says to use the functions. So please don't just turn in the same exact assignment from last week. You have to change it up according to the assignment specification. Okay. And some of it will be similar to what we just did right here. This is how we made a function. For your assignment, I think you have to have like a function that calculates the cost of the house cleaning, right? For those of you here tonight, and for those who may actually watch the video, I'll give you a little bit of help here, right? If I were to make a function that computes, how much it costs to clean a house, what does that look like? Well, first we got to start off with DEF. DEF stands for define, and it just means I'm getting ready to make my own function. We need to name it something. So we'll say name of it is calculate the cost. And now inside the parentheses, what does our function need to know in order to calculate the cost? What does it need to know? Well, it needs to know the size of the house, right? Size of house. It needs to know if it's a small, medium, or large house, right? It also needs to know the type of cleaning, right? Those are the two things that our function needs to know in order to calculate the cost, right? And now we do some calculation, and then we're going to return whatever the cost is, right? And so since that's our function, let's actually use our function. We'll say the cost is equal to calculate the cost of a small house that is, I don't know, cleaning windows or something, right? And then we'll print out the cost. That's something along the lines with how you should be looking at doing your assignment. This isn't covering everything, and there's some stuff in here missing, but that's for you to figure out. I'm not going to give you the whole answer, but it should kind of somewhat look like this, using a function to calculate the cost of the cleaning. Again, this is the name of the function. Then we have a parentheses. Inside here are the arguments. What does my function need to know in order to calculate the cost? It needs to know how big the house is and what type of cleaning you want. Based on those two things, you do some kind of calculation to figure out the cost, and then you return whatever that cost is. And then here after our function, it's not tabbed over, so it's not part of the function. We're going to say this variable cost is equal to whatever this returns. And then we're just going to print that cost out. Okay, so that's everything for this week. And so I will go ahead and open up for questions. You can unmute yourself and ask, or just type something in the chat box.
Yeah, I've got a question. Would there ever be a instance where you, in the return portion of the function, where you wouldn't, what you typed in after return would be something different from what you have inside of the function?
Are you asking if we can have something after the return?
Yeah, so like when you had the area function up, you had return area. If there was something else other inside of the function that wasn't area, would there be a reason for you to use that instead of area? I don't know if that.
Well, yeah, I mean, you can return absolutely anything you want to. I could return blah, 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 right? I can return that. And then watch this down here. If we run this, I type in a radius of 4, but it prints out blah, blah, blah. Why? Because I said the area is
Okay.
equal to whatever this returns. And then I'm printing it out. Well, it turns out that's what it returned. Now,
Okay.
that's not very useful because I expected
Sure.
it to compute the area of a circle. But yes, you can return absolutely anything that you want to. But
So is
you
the
know,
return function kind of acting like a print almost in the
no,
way that
no, the return does not print anything. What's happening here is, let me change it back to the real answer, change it back to area. What's happening here is this variable area is going to be equal to whatever this returns. Okay. So this function, it does a computation and then it returns a number, right? Whatever this computation is actually just a number. And so this variable is equal to that number. And so I'm saying return that number. And so down here, I'm saying this area is equal to that number that got returned. And then I'm printing out the number. So if I would leave out this print statement and just run the program, see, it doesn't print anything because return is not a print. It just gives back whatever you want it to give back. In this case, this area is a number. Now I'm saying, okay, this is equal to whatever that number is. So now if I want to print it out, I have to explicitly print it out like that.
okay, yeah, that makes sense.
Okay.
Yeah.
One thing I want to add in here is, when you're doing if else statements and stuff like that, let's do our house cleaning thing again. Calculate the cost, size of house, and type of cleaning, right? So you can see a return. There can be more than one return statement, but the return will only happen one time. Let's see what I mean. Let's just say if the size of house is small, notice I'm using an if statement here. Then let's say I want to return $100. Else, if the size of the house is medium, I'm going to return $200. Else, return $300. I mean, this is simple. I'm ignoring the type of cleaning, right? Because this is just for example purposes. For your assignment, you need to take into account type of cleaning and stuff. But even though I have multiple return statements, only one of these actually happen, right? And that's because, if I would do cost is equal to calculate the cost of a small house, right? Print cost. What will it print out here? Should print out the 100, right? Oh, I have an error. Why do I have an error? This is one position. Oh, yeah. Give me an error because another good teaching point is this function, it expects two things, right? It's expecting you to give it these two arguments. I made a mistake and only gave it one. So it actually needs two. So let's say I give it small in Windows. Now let's run it. And it gives us 100, like I expected it to. So even though there are three separate return statements, only one of them actually happened. Why is that? Because when I do calculate costs, these are the two arguments, small and windows. That means the size of the house, it is small. The type of cleaning is windows. And it's that way because these are the two arguments, and they kind of get, I don't know the best word to use, kind of copied over, I guess is the best word, to where small gets copied into the size of the house, windows gets copied over into type of cleaning. So up here in the function, the size of the house is the small, the type of cleaning is windows. So now when we're doing this, because of these if statements, that is the only return that happens. If the size of the house were, say, medium, that should give us 200, and it does. Even though there's multiple return statements, only one of them actually happened because of the if statements. If we would have something like this, actually, let's forget about the whole if statements altogether. We could just return 100, right? If we run that, we get 100. It's not really doing any calculation, but this is what's given back to us. What if we would have two returns like that? What happens here? It's actually still just 100. The reason is, whenever your code is running, as soon as it gets to the first return statement, that's the end of it. That function stops and it goes back to where it left off. So it never gets here to this other return statement. So that's how you can have multiple return statements, but only one of them will ever happen. All right. Any other questions? All right. I will stand by about 30 more seconds or so, if anything, if you should think of anything. So standing by before we wrap it up. All right, nothing heard. We'll go ahead and wrap it up. As I've said multiple times before, the earlier that you ask me for assistance, the more assistance that I'll be able to give to you. Yeah, I do have a question. I did have a question about syntax for return of a line. Oh, that just somebody let me know there's an email. Okay. The person who directly asked me that question, I'll answer it to you. Just stay online for a second. All right. Other than that, we'll go ahead and wrap it up, and everybody have a good night.